In section 5.4, we're going to learn about using the sum and difference identities. You do not need to memorize these identities for the test, as I will give you this box. You just have to be able to use them in the particular problems. So we have our sum identities here, which is the cosine of alpha plus beta is the cosine alpha cosine beta minus sine alpha sine beta. We have the sine of a plus b, and we have the tangent of alpha plus beta. Then we have our difference identities over on the right. So instead of adding inside, we are now subtracting inside with cosine, sine, and tangent, and their formulas are following. So let's take a look at example 1. We want to find the exact value of each trig expression. In letter A, we have the sine of 15 degrees. Now let's think about, we want to use our special right triangles if we can. In order to get an exact value, those are the ones we want to use. So numbers we're thinking about using in degrees would be 90 degrees, we have 45 degrees, 60 degrees, 30 degrees, and so forth. So we could use any of those reference angles, or these are the main reference angles, but then any of those in the other quadrants, so like 110 degrees or 180 degrees, anything that has the 90, 45, 60, 30 triangles within them are things that you might want to use. So if we look at 15 degrees, how can we make 15 degrees from these numbers? Well, if I look at 45 and 30, they're only 15 apart, which means if I subtract them, I could get 15 degrees. So I'm going to use that one. So I can rewrite sine of 15 degrees as the sine of 45 degrees minus 30 degrees. Because 45 minus 30 is going to give us the 15 that we want. So these are equivalent. Now what I have is I have something in terms of the right triangles that I know, and I have a difference formula. This is the sine formula. So it's the sine of alpha cosine of beta minus cosine of alpha sine of beta. In our problem that we have, 45 would be the alpha and 30 would be the beta. So we can rewrite this using that difference formula as the sine of 45 degrees times the cosine of 30 degrees minus cosine of 45 degrees times the sine of 30 degrees. And then what we're going to do is we're going to evaluate each one separately using that right triangle trig or using that unit circle that we did back in chapter 4. So what is the sine of 45 degrees? Well, the sine of 45 degrees is just square root of 2 over 2. The cosine of 30 degrees, if you don't remember, we can make a quick reference here. If we're in the first quadrant, here's 30. Across from a 30-degree angle is 1/2. So the cosine of 30 degrees then would be the x, which would be across from the 60, which is square root of 3 over 2. Minus cosine of 45 is just square root of 2 over 2. And the sine of 30, then, again, looking back at our picture, sine would be the 1/2. And then we're going to simplify. Order of operations tells us that we want to multiply before we do the subtraction. So we can multiply square root of 2 times square root of 3, which is square root of 6. And then in the denominator, 2 times 2 gives us 4. Minus, over here, square root of 2 times 1 is just the square root of 2. And again, 2 times 2 on the bottom would give us 4. Then we can write this as just one fraction, since they have common denominators already. We can write this as the square root of 6 minus the square root of 2 all over 4 as our final exact answer. Next, what we need to do is we need to come up with the tangent of 7 pi over 12, and we need to find something that we can add together, some of our special right triangles. So what we're thinking of now is we want to use radians instead of degrees. So we're thinking about our pi over 3s, pi over 4s, pi over 6s, and pi over 2s. In any form of those. So depending on what number you have to start with, we could use, 2 pi over 3 or 3 pi over 4 or 5 pi over 6. Any of those options where we can get that. So what we're looking for, first of all, is a denominator of 12. So what I need to do is figure out how can I get 7 pi over 12 from what I have. Now my first thought is, wow, over 12, maybe that's going to be something with pi over 6 because 6 and 12 tend to go together. And so to check to make sure which ones you have, what I would do is just take that angle and ignore the pi's for now. Just look at the 7 over 12 and subtract 1/6. So using a pi over 6. Again, the pi's we don't really need. And if you don't want to do it by hand, you could just do it on your graphing calculator. Take 7 over 12, subtract 1 over 6, and go ahead and do that on your calculator, or you can do it by hand, get your common denominators. And if you do that, you see that you get 5 over 12. Well, subtracting 1/6 gives us 5 over 12. Is 5 over 12, if we add the pi in there, is 5 pi over 12 one of our special right triangles? And the answer to that is no. So we know that's not going to work. So let's take another one. And again, there's no really right or wrong way to do it. So let's try pi over 3. So if you take 7 over 12 and subtract, again, ignore the pi's for now, subtract 1/3, what do you get? So you can, again, do it by hand, get common denominators, plug it in your calculator, but do that for a second. Take 7 over 12 and subtract 1/3. And what you see is you get 1/4. Well, putting the pi's back, could we use pi over 3 and pi over 4? And the answer to that is yes. And so what we could do, if you think about it, if I move this 1/3 over, 1/4 plus 1/3 is the same thing as 7 over 12. And so that gives us the angles that we want to use. Now I'm going to move or get rid of these just so I have some room here to write. And I'm going to rewrite tangent of 7 pi over 12 as the tangent of pi over 3 plus pi over 4. And finding those angles is probably going to be your most difficult part of this. So if you need me to walk you through it a little bit more, let me know. Then once we have this, we want to do the tangent of pi over 3 plus pi over 4, which is a sum identity. So let's take a look at that tangent sum identity, which is right here on the top. And we have the tangent of alpha plus the tangent of beta on the top. So we're going to have the tangent of pi over 3 plus the tangent of pi over 4 all over 1 minus, so again now we're in the denominator, 1 minus, and we're going to multiply the two tangents together. So tangent of pi over 3 times the tangent of pi over 4. Then we need to evaluate these, so we need to figure out what is the tangent of pi over 3. So let's think about that. If we draw our triangle out, pi over 3 is in our first quadrant with a reference angle of 60 degrees, giving us square root of 3 over 2 here and 1/2 over here. And remember, the tangent is sine divided by cosine. So we're taking the square root of 3 over 2, and we're multiplying by the reciprocal, which is multiplying by 2, which is square root of 3. So I get square root of 3 plus tangent of pi over 4. Hopefully by now we know that's just 1. On the bottom we have 1 minus tangent of pi over 3 we already found is the square root of 3 times the tangent of pi over 4, which we know is 1. So simplifying the denominator here, we can leave the numerator as it is, square root of 3 plus 1 over 1 minus the square root of 3. You do not have to rationalize for this. You can leave it unrationalized and then simplify it just like this as square root of 3 plus 1 over 1 minus the square root of 3. If you have questions, let me know. Otherwise, I'd like you to go to the try this and try the sine of 5 pi over 12. So pause it now, unpause it when you're ready to check your answer. If you did the try this correctly, you should have changed this originally to the sine of pi over 4 plus pi over 6. And if you did it correctly, your answer should be the square root of 6 plus the square root of 2 all over 4. If you have questions, let me know.